Hello, my name is Rob Reynolds. Welcome to Math-073. Today we get our last section of the conic sections. We've been studying parabolas, hyperbolas, ellipses, and circles, all the different forms of the conic section. And today we're going to look at their systems of how they could intersect. So we have an ellipse, maybe intersecting an ellipse. And so we're going to find these points of intersection. There could be 4, there might only be 2, and there could be 3. So here's an example where there's only 3. So and then we're going to look at maybe where this would be applied. So in what ways do you think that a circle could intersect a line? Well, we've got a circle. It could not intersect at all, so no solution. It could intersect once, or it could intersect twice, and I think those are the only 3 scenarios. There's no way for a line to intersect a circle 3 or more times. So sometimes it's kind of good to look at what type of function. If it's a hyperbola, it could potentially cross 4 times is I believe the max, but it could be 3 or 2 or 1, and remember there is a no solution out here too. So if you see a first degree system, it's probably recommended to do the substitution method. And a first degree would be something like a linear function. So I would try a substitution if we let y equal 2x from this bottom equation and plug this 2x into the top equation. I get x plus that y term squared, and that y is really the 2x. Then I have everything in terms of x, and I can back substitute. So x plus 4x squared is a whopping 5x squared, and then I'll divide everything through by 5. X squared equals 4, therefore x, remember every time you take the square root you get 2 answers. So I get a positive 2 and a negative 2 for solutions. Well, to find the y values I need to go back and evaluate the function, and it doesn't matter if you go to the function A or function B, either one will be fine, but I'm going to choose function B because it looks a little bit easier to deal with. So in fact, I think I would really prefer to go to this equation down here because it's already solved for y. So y is equal to 2x. Then I'll just double it. So double this is 4, and double this is negative 4. Now be careful, I'm doubling it. So negative 2 times 2 is negative 4. You don't want to square it because negative 2 squared is a positive 4. So I believe my 2 answers are here and here. We'll see how the author worked it out. Looks like something similar. Good. They got positive 2 and negative 2, and there's the 4 and the negative 4. They've actually graphed the function, and so you can see over 2 up 4 is a solution, and this is 2 to the left, and so negative 2, negative 4, and there's the solutions. So again, we have all sorts of different types of conic functions that could intersect each other. Here are some common ways that it could intersect: 4 solutions, 3 solutions, 2 solutions. Here's another 2 solution scenario where it could just be the vertices, 1 solution or no solutions. If you have a second degree and both equations are second degree, instead of doing the substitution method, which I did on the first example, I think the easiest way for a second degree equation is to use the elimination method. Let me show you what I mean. There's nothing nice to solve for in either equation A or equation B, so I'd probably use the elimination method. Let's try to get rid of, well, I'll go for the y's. It doesn't matter if you go for the y's or the x's, but I'll leave equation A alone. 3x squared plus 2y squared equals 66. And I know that if I were to get a negative 2y squared here and add it, my y terms would eliminate. And to do that, all I have to do is multiply both sides by 2, giving me 2x squared equals 14. I'll add this up. 5x squared equals 80. Dividing by 5, x squared is 16, and x is plus or minus 4. So again, I'll write some solutions, positive 4 and negative 4. And to find the y values, I'm going to choose one of the equations. I'm going to go to this guy right here, and let x be 4. So 4 squared is 16. So 16 minus y squared equals 7. Negative y squared equals negative 9. So y squared is 9, and y is plus or minus 3. So this actually gave me a 3, but it also gave me a negative 3. So I'm picking up more answers. And frankly, if I were to plug in the negative 4 here, it would still end up to look exactly the same. So I'll end up with a 3 and a negative 3 for that as well. So it looks like there's 4 solutions. And I won't graph it here for you, but the author seems to agree here. So a third example, again, substitution. So it's already solved for you. So we'll plug this in for the y value. X plus 3 minus x squared equals 5. I'd probably set this equal to 0. X squared minus x plus 2, and then I'd try to factor it, but there are no factors of 2 that add up to 1. Now that doesn't mean that there's no solutions, because they may not be rational solutions. So you'll actually have to check the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And now I'm convinced, because I'm taking the square root of a negative, that there is no solution. You really need to go all this way to check that yellow number. It's called the discriminant, b squared minus 4ac. Since the discriminant is negative, then I say that these graphs never intersect. But I wanted to show you it's possible that this, even though it doesn't factor, might still have irrational solutions. So don't stop here just because it doesn't factor. So good. The author went all the way to the imaginary solutions. You don't need to go that far. But the point is there's no solution. So no real number solutions work here. I don't think the book will ask for the imaginary solutions. Another example would be, well, this is a substitution problem probably too. Maybe I'll solve for y. I could solve for x as well. And I'll take this y value and plug it in up here. So I'll get x squared plus 4 times the y value equals 20. I'm going to choose to multiply everything through by x. Oh, I don't need to do that because I forgot this thing is being squared. So this is actually x squared plus 4 times 16 over x squared. So now I can get, now I can multiply through by x squared every term, or both sides. I still have an x to the 4th. I was trying to avoid that. 16 times 4 is 64 equals 20x squared. Well, I suppose I can just set this equal to 0. Let's put the 0 on the other side. So let me erase this. So if I say x to the 4th minus 20x squared plus 64 equals 0, I'll try to factor this. And again, if it doesn't factor, they'll try the quadratic formula. So factors of 64 that add up to 20. I think 16 and 4. Signs are alike. They're both negative. X squared, x, oh my gosh, there's going to be a lot of solutions here. Signs are alike, they're both negative. So x squared equals 16, so x equals plus or minus 4 here. X equals plus or minus 2. Oh my gosh, there's a lot of solutions here. So x is plus or minus 4, plus or minus 2, and then you would take all those, plug those back into, so there's your positive 4, there's your negative 4 solution, there's your positive 2, there's your negative 2 solution. That was a long problem. An application to this would be this word problem where you have a picture frame and you're given that the area of this picture frame is 216 inches squared. The perimeter, which is defined as twice the length plus twice the width of the frame, is 60. So it's kind of saying 60 is twice the length plus twice the width. Oh, and this guy really means that the area, 216, is equal to LW. So look at this. I think I have my systems. twice the L plus twice the width. So just like the last problem, I think I could take the top L or W, doesn't matter. I'll take the top equation, solve it for L, and get 216 divided by W, and plug that in right down here. So 60 is equal to twice 216 divided by W plus 2W. I'm going to choose to multiply both sides by W again because I just don't like this W in the denominator, and that will wipe it out after I distribute. So 60W is equal to 432. The W canceled. 2W squared. So setting this equal to 0, 2W squared minus 60W plus 432. I'm going to choose to divide everything through by 2. Make the numbers just a little bit smaller. So I'll take half of everything. Half of 432 is 216. And then I'm going to look for factors of 216 that add up to 30. And I think that's 12 and 18. Signs are alike. They're both negative. So W equals 12, W equals 18. If the width is W, I'm going to go back to this. I know 216 is LW. Oh, so if the width is 12, that'll make the length 18, and if the width is 18, that'll make the length 12. But basically I've got 12 and 18. It makes sense to have the length is usually considered the longer side, so we'll let length be 18 and the width be 12. You can check your answers by plugging it back in and make sure that your area and your perimeters are correct. And I think that works out, and then you state the final answer. I hope you found this video helpful. If you have any questions, please feel free to email me.